All right, so next topic for this week is conditional probability, and we only have two problems to go over for this. I think there's only going to be one problem in your homework, but I feel like two problems will give you a better idea of how this works. So, the conditional probability of event B happening, given that event A happened, is the probability of event B assuming that event A has or will or occur. And we use this notation, the probability of B, and then it's like this straight line A. We read it B given A. So let's take a look at this first problem. Emma is playing Monopoly, a game played with two dice. What is the probability that the sum of the two dice she rolls is less than 4, given that she rolls an odd number? So really, all we have to do with these problems is just think about them a little bit more, because there's some condition. And in this case, our condition is that one of the dice that she rolls is an odd number. They don't say they're both odd. She's just saying that she rolls an odd number. So one of those numbers has to be odd. They could both be odd as well, but again, at least one of them needs to be odd. So let's think about this. What are the different sums we can roll less than 4? So again, less than, when we say just less than, that means we're not including 4. So it's not less than or equal to, it's strictly less than. So the different sums we can actually roll are, well, we can't get a sum of 1, right? Because any two die that we roll, the lowest numbers we could get are 1s, and 1 plus 1 is 2. So we can roll a sum of 2, or we could roll a sum of 3. Right? Those are the two numbers, the two sums lower than 4. All right, now let's list out the different ways we can roll a sum of 2. Well, there's only one way. Okay, a 1 and a 1. What about a sum of 3? We can roll a sum of 3 if we roll a 1 and a 2, or sorry, a 2 and a 1 or a 1 and a 2, because remember, we have to account for both versions. And, so these are all the possibilities of rolling a sum less than 4. And then we just want to make sure we're only really counting the ones that include an odd number. So this really wasn't the best example. I took this one straight from the book that we're using. Because if you look, every one of our pairs has an odd number. This has an odd number, this has an odd number, this has an odd number. So we can go ahead and count these. But basically, if you had some sums that weren't all odd numbers, or didn't have an odd number at all, then you wouldn't include those. So that's what I meant with, we just have to think about these problems a little bit more. We just might not count every piece as we normally would with regular probability. Because again, this is conditional. There's a condition that we have to check, essentially. But our condition's good. In each of these pairs, there's an odd number. So how many ways can we roll a sum less than 4? There's 1, 2, 3. Out of, again, there's always 36 possible ways to roll 2 dice. So 3 out of 36 is going to be our answer for this one. Let's go ahead and look at another one. So hopefully this will give you a better idea. And this one is, you may see on your homework, or something similar, because it does kind of, change the problems a little bit. A swim team consists of 4 boys and 3 girls. A relay team of 4 swimmers is chosen at random from the team members. What is the probability that there are 2 boys on the team, given that there are 2 girls on the relay team? So we want to know the probability that there's going to be 2 boys given that there's already 2 girls chosen for this team. Okay. So once again, basically we just need to think about this a little bit more as we determine our probability. Now, notice that we have this group of people and we're choosing people out of that group. That should sound familiar. This is either a permutation or a combination. Right? Remember with permutations and combinations, we were always choosing people out of a group. And the big question was, does order matter? And here they're just mentioning that they're just trying to pick the members of this relay. They don't mention putting them in a specific order or anything. So order does not matter here. So this is a combination. So we're going to be using the combination formula, NCR, which is equal to n factorial over r factorial times n minus r factorial. If you feel more comfortable using the formula, this is what you will use. All right, so let's actually set this up. So remember, anytime we do probability, it's on top is, what we're looking for. And then the bottom is the total number of possibilities. So we're trying to figure out the probability of picking out these 2 boys for these last 2 spots, right? Well, how many boys are on this team? There's 4. There's 4 boys, and we want to choose 2 of them. So I'm going to use 4, choose 2, right? Using this notation, NCR, there's 4 boys, and we want to choose 2 of them for the relay. And that's what we're focusing on, right? That's what the main object of why we're determining this probability is, choosing those 2 boys. But then on the bottom, we need the total number of options we have. And this is where we need to think a little bit deeper. So how many total people are on this team? There's 4 boys and there's 3 girls. So there's 7 total people on this team. Now, this is a conditional probability problem, however. So they told us that 2 girls have already been chosen, right? They're already on the team. So if we consider that 2 of these girls have already been chosen, how many people do we have left to actually pick from for those last 2 relay spots? There's 5 people left. Now, there was only 3 girls. 2 of them were chosen for the relay team, but that still leaves another girl that could technically be chosen. So there's 5 people left to be chosen, 4 boys and 1 girl. So on the bottom here, the total number of possibilities is 5, choose 2. Right? Because there's 5 total people we could pick from, and we only want to choose 2 of them. All right. And then you would plug everything into your formula for here. We get 4 factorial over 2 factorial times 4 minus 2 factorial, all over 5 factorial over 2 factorial times 5 minus 2 factorial. And let's simplify. So on the top, we're going to have 4 factorial over 2 factorial times 2 factorial. On the bottom, we'll have 5 factorial over 2 factorial times 3 factorial. And then I like to do some cancellation. Let's go ahead and deal with these one at a time. So for the 4 factorial, I'm going to peel off numbers until I get to a 2 factorial, because then I can cancel one of those out. So we have 4 times 3 is 12, and 2 factorial is just 2 times 1. So we actually get 6 for the top number. And then on the bottom, I'm going to peel off numbers, so 5 times 4 times, and then I can cancel out that 3 factorial, so I'm going to stop there. Cancel those babies out. We get 20 over 2 factorial, which is just 2, and 20 over 2 is 10. So we get 6/10. If you pop that into a calculator, that's 0.6. Now, you wouldn't want to just type 6/10 in for your answer into Hawks because this is not a reduced fraction. We could reduce this by dividing by 2. We would get 3/5. So you could do 3/5 or 0.6. All right. So in this homework assignment, that should be the only one where we're having to bring back the permutations and combinations. So just know that in section 7.4, there's only one problem that you're really going to have to do that with. The rest of them are just kind of the regular probability. Okay, so those are the 2 topics from section 7.4, but we also have one more section to cover, section 7.5, and I will be covering that in the next video.